This is Matt from TAFE New South Wales, and in this video we're going to be looking at basic dimensioning types, techniques and settings used in the AutoCAD 2020 software. In order to show you how we're going to be using these different types of dimensions on your typical drawing, I've just come up with a little exercise here to the side that we're going to be using, and hopefully I'll be able to use that to demonstrate the most common dimension types and how they're applied. So let's have a closer look at that. So here you'll see that we've got a number of different types of objects. We've got lines that are at different angles. We've also got a circle. We've got an arc. We've got a cutout here that'll need to be dimensioned and all that sort of thing. So this is a fairly typical example of a simple profile that'll need dimensioning. But before we start applying dimensions, one of the first things we need to do is to make sure that our settings in that are correct. Now, this video is not about creating or modifying the different styles and settings required, but first what we want to do is to make sure that we've got the correct styles and that activated. To do that, go up to the Annotate tab on the ribbon. Click on that and you'll see the first couple of sections are about text and dimensions. What we just need to do is to make sure that we've got the right style selected. So with the template that I'm using here at the moment, I've got text and dimension styles called drafting. And it is these styles that look after the basic settings for both text and dimensions. Things like arrowheads, arrowhead sizes, offsets, dimension lines, the type of text, the way it looks, where it sits and how it sits. The ones that I've got here are designed to most closely align with the Australian standard AS 1100. But obviously if you're receiving drawings from other people, their standards or the settings they use might differ, so do be aware of that. Once we've done that, we'll go back to the Home tab because we want to make sure, firstly, that our layer that we're going to be putting these dimensions is set up for the dimensions. It's a really good idea to always have a different layer for dimensions, make them a different color to make them stand out. And also it's very important to make sure here towards the right in the properties palette that all the properties are set to by layer. Almost without exception, it is always better to control the properties of any drawn object or text or dimension or anything like that using the settings within a layer. Modifying the properties of an individual object using these property overrides can really cause problems down the track when you're trying to sort of get drawings to come to a particular standard. So best to avoid that. So we can access the basic dimension types that are most typically used, and there's 5 that we'll be looking at in this video, either from the Home tab and going across to the Annotation panel, and then you'll find here we've got the dimension types. If we click the little down arrow, you'll see a number of different dimension types there. The 5 we're going to be concentrating on this video are linear, aligned, angular, radius and diameter, which are the most common 5 dimension types. Another way of accessing these exact same commands is through the Annotate tab, and there you'll see the exactly the same thing again, but you can access them a little bit differently. Here we've got them in the dimensions panel, and we've got the same 8 types there again, including our 5 common ones, and we've got a couple of other options in here such as quick dimension, continue, baseline up here, obliquing. That's stuff that we'll be using later on, and we'll come back to that then. So once you're satisfied that all your settings are good to go, that you've selected the right layer, then you can start applying your dimensions. Now, a linear dimension is designed to apply a dimension that measures either horizontally or vertically, regardless of whether the points you're dimensioning from and to are aligned horizontally and vertically. I'll show you what I mean by that. So if I select the linear dimension, I'm going to make sure that my object snaps are on. That's very important, so that I snap to an object, snap to another object, pull the cursor away, and the third click of the mouse puts the dimension in position. We want to offset it from the object so that it looks about the right proportion, and the distance from the dimension to the object should be somewhere in the vicinity of that 10mm mark. So that's given us a horizontal dimension, but because our 2 points here were horizontal, that was kind of going to happen anyway. But what about if we want to measure the horizontal component between these 2 points? If we now do a linear dimension between these 2 points, you'll see that if we move the cursor upwards, we get a dimension that's linear. If we move it to the right or to the left, we get the vertical component of that dimension. So it's about picking the 2 points and then putting the cursor in the correct position so that you get the dimension that you want. So that is a linear dimension. Okay, so that it always aligns. Another place where that's commonly used is to dimension two center lines of objects or features that are within the profile that we're dealing with. So again, from a corner to the end of a center line is the best way to do it. That will give me that dimension there. I can repeat the process again from the same corner but to there, and again this is a linear dimension. So that's the basics of how that one will work. So you go through putting on as many linear dimensions as you thought you needed. Our next dimension type, if we go up here and click the little drop down, is the align dimension. Now the align dimension does just what it says. It gives you the straight line distance between whichever 2 points that you pick. So it's not about a horizontal or vertical component, but literally a straight line. So if I were to do that to this same location, you'll see that we get a very different dimension because it's measuring the actual length of that line, not just one component of it. This is the sort of dimension that'll be used to measure any line, the length of any line that's on an angle. So if it's not vertical or horizontal, you'll need to use the aligned dimension, and also sometimes used for measuring other objects, such as from a center point to center point or something like that. So for example, I could measure from center point to center point. That's a pretty unattractive looking dimension to put in there though. So there are two basic linear dimensions that we use. Okay. Another one that's very common is the angular dimension. So if you've got two lines that are at an angle to each other, and they do not have to intersect, as long as they are not parallel to each other, they don't have to intersect, you can put an angle dimension between them. So left click here and we come down to our angular dimension, and again click on the first object, click on the second object, and then move the mouse in the direction where you want the dimension to appear. You'll see the further we move the mouse, it adds its own extension line as needed and extends those, and if we move the mouse we actually have a number of different alternate placements or locations where we can place that dimension. So we'll left click there. Now when you're dimensioning objects, it's very important that the dimensions are not inside the profile. So that leads to a very confusing drawings, and it's also best to avoid any dimension lines crossing into the profile wherever possible. Of course that's not always possible. These two dimensions down here are an example where you've got the dimension line crossing into the object. So that's our angular dimension, which is applied to those. Our fourth one is our radius dimension. Now generally speaking, a radius dimension will be applied to any arc, whereas a diameter dimension will be applied to any circle, but it really depends on how that object's actually going to be manufactured. So for example, this arc here is most likely to be made or marked out or machined, and the information that the operator would need in order to manufacture this part would be they'd need to know the radius of that curve. If they're marking it out on a piece of timber or a piece of steel or plastic, they would need to find this center point. they would then need to actually mark or scribe that radius. So it's the radius value is what they need. So when we activate the radius, unlike the linear, aligned and angular constraint, this only needs 2 clicks, not 3. We click the arc that we're putting the dimension on, or the circumference, move the cursor away from the object, and then left click again to put it in position. You'll notice that the point of the arrow for both radius and diameter dimensions will always point to the center of the circle. Okay, so and that happens automatically when you use your dimension styles correctly. If we then have a look at applying a diameter dimension, now diameter dimension is almost always used if it is a hole that you're putting a dimension on, or if it's a machined part or a pin. Those are almost always made, and the equipment used, either a drill bit or a lathe, references diameters, not radiuses. So we want to use the diameter dimension because it saves the operators making additional calculations. And every time somebody has to make an additional calculation, especially if it's on a workshop or factory floor, in their head when they're in a hurry and trying to get stuff done, there's more likely to be a mistake made. So your job as a draftsperson is to supply the information that they need to make the object as efficiently as possible. Of course, anything that you dimension needs to carry enough dimensions that it can be made. Now, if you underdimension an object, that means not enough information has been supplied to actually make it. Now, that is almost as big a crime, over-dimensioning an object is almost as big a crime as under-dimensioning an object, because putting too many dimensions makes a drawing more complicated, harder to read, harder to understand, and again, the people reading your drawing are more likely to make a mistake. So what we need to do is keep things as simple as possible. If you've got a particular situation where adding an extra dimension is going to save somebody from needing to make a more difficult calculation, then I would err on the side of caution and add the extra dimension, even though technically it might not be needed. But make sure you don't over-dimension your drawings. That's probably about enough on basic dimensioning practices. Those 5 different types of dimensions that we've looked at today are certainly the ones that are most common in all the initial exercises that are part of our drafting courses. So hopefully that'll help you. If you've got any questions, make sure you review this video as required. Make sure you apply these different dimension types, techniques and tricks that you've been taught so that you retain them. And this is something certainly that every draft person needs to know.